All right, here's EKG number 11, and so let's look at this one. Again, let's go through it real quickly. The rate, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 60. You know what? This one looks different than the rest. So this is some other kind of beat. It's an ectopic beat, okay? So the rhythm is going to be, let's see, well, there's a P, QRS, P, QRS, P, QRS. No P, because this is some ectopic beat. P, QRS, P, QRS. So I think this is a sinus rhythm here, okay? The axis, F is down and 1 is up. So negative F, positive 1. We're in this quadrant over here, so we got to look at 2. Oh, 2 is, that's a close one. I'll say it's mostly negative, right? So we're on this blue side of the line here. So we have a left axis, okay? So we got heart rate of 60, rhythm is sinus, axis is left. Let's look at our intervals next. And even from this big zoomed out view, we can see that the P and the QRS are about one big block apart, so we'll say that it's less than 200. The QRS, oh, that looks kind of wide actually, right? This doesn't have that nice narrow picture that we had before. And so it's a wide QRS. And the QTC, we can say you can draw a line here. Let's pick a non-ectopic beat actually. Let's draw a line here in the middle. So the QTC, the T is on the proper side, so the QTC is less than 500. ST segments, well, we got some T wave inversions here. So we got some lateral T wave inversions. Let's look here. We do again have some lateral T wave inversions. So we have some lateral T wave inversions, okay? Let's look inferiorly. Inferiorly, ST segments look good, T waves look good. And then anteroceptorally, we got T waves up, and these things look fine. So we have some T wave inversions laterally. Let's talk about that wide QRS quickly, though. And so I'm going to zoom in here for a moment. And you'll remember we have an SA node, an AV node, we got our bundle of His, and then our bundle branches. And so sometimes you may actually get a break in one of the bundles, right? And so what happens is these bundles are what are responsible for transmitting signal quickly throughout the ventricle, right? You don't want this part of the ventricle to contract first and then this part later. You want it all to contract at once so that the blood pumps effectively. So that's why you got to get these superconducting fibers. You have them here so that when signal goes through here, it almost instantly goes all the way around the heart. But if you have a break in one of these wires, then it can't get there quickly. So it's going to, in this case, I broke the right one. And so it's going to get here and stop, and now it's got to meander slowly through the heart because it can't go through these superconducting, super fast wires. But the left side can go fast. Similarly, you can have the opposite happen, where you have a break in the left side. So the right side can depolarize quickly, the left side stops, and it's got to slowly meander through the ventricle. So you're going to have a picture that looks like the first part going fast, the right side going fast, and the left side slow. Now you can remember all that, or you can remember this handy mnemonic, William Merrow, okay? And what this says is that if V1, this is V1 and this is V6. So V1 looks like a W and V6 looks like an M, it's a left bundle branch block. If V1 looks like an M and V6 looks like a W, it's a right bundle branch block. Okay, I drew this perfectly covering what we need to look at, so I'm going to move it. So let's take a look. Now they're not going to look like good letters, good examples of the letters. They're going to look like terrible representations, but you'll get what I see. So you can see here, there's a tiny downward deflection, then it goes like that. And so this kind of looks like a W, and then over here looks like an M, right? That looks like an M. So you would say W in V1, M in V6 is a left bundle branch block. Now if it was the opposite, if you saw an M in V1 and a W in V6, you would have a right bundle branch block. If you want to get in more detail on this, there's a video on the QRS intervals that you can watch, and it'll show you why this actually happens. And it has to do with where the leads are, right? Because V1 is over here and V6 is over here. And if V1 is going fast and V6 is going slow, it looks like different things. But I think this mnemonic works pretty well. I use it rather than trying to memorize why everything is happening. It's good to know why it's happening, but there's that mnemonic. So let's zoom back out here. Okay, so what did we say before? I think we said that we had some T wave inversions in the lateral leads, which we do, and sometimes that happens with left bundle branch block. So it's important to look at an old EKG and see if that was there before. Does this represent something new, or is it something that we have to worry about, that we don't have to worry about because it's old? So we have a left bundle branch block in this EKG. Now, it used to be said that a new left bundle branch block should be considered an MI unless you can prove otherwise. And so that's not necessarily true, and maybe in the future they're going to say that, we don't have to think that. But for right now, and I think probably for your test, a new left bundle branch block. So you get an old one, and it is not a left bundle branch block. It's a nice narrow QRS. And now you have one that shows a left bundle. Worry about an MI, a myocardial infarction. Okay? And so that patient would need to go to the cath lab. In this case, I would probably talk it over with the cardiologist or your ED attending and decide whether you want to call this a myocardial infarction or not. Okay, that's the last of these EKGs. If you have any problems, please email me, call me, talk to any of the attendings in the department, and we can help you with reading these. Thanks. Bye.